Hello there. Let's do the question with a combination of two solutions. So you're given, in this case actually, what we should be thinking, M1V1 plus M2V2 goes into M3V3. Basically, we have solution A and solution B and turning into a solution C, right? A plus B will give you solution C. So it's a little bit complex one. Think about three beakers in this case. First beaker has 75 mils with zero point 0.2 molar ammonium sulfide. And so the formula you can copy from the book, right? And then the beaker B, so let's make this a little bit proportional so you can see the 75 mils versus 25 mils in the beaker B, and its molarity is zero point 0.4 molar, and it's ammonium chloride. Now you're going to mix these two beakers together into one beaker. So that's why 75 ml plus 25 ml makes the 100 milliliter total. That's important, the total volume, because you're going to calculate the molarity later. So visualization of these two beaker going into one beaker is really important to understand the chemistry behind it. So look at this one. So you will get two portions of ammonium from A and B. These are different amounts of moles. And so let's make it bigger. It's 75 plus 25, which is 100 mils roughly. It looks bigger beaker, right? And then you're going to divide by the total volume is 100 milliliter divided by 1000 mil. That's 0.1 liter. That has to be liter, right? And also you will have a different value for chloride moles and different value for sulfide moles, and they also should be divided by the total volume, which is zero point 0.1 liter. This cannot be milliliters, right? Because you are looking for the molarity. Now go to the ammonium sulfide, the first compound. So this one has the molarity of 0.2 molar, and it's in 1 liter initially, right? 1 liter means the molarity is expressed 0.2 moles in 1 liter. But this 75 mil, I'm going to convert into liter because it's easier, divide by 1000 mil, and 0.075 liter. The liter to liter cancels out. You get the moles of ammonium sulfide, 0.015, right? So now if you divide by the total volume of zero point 0.1 liter, that's the new concentration of ammonium sulfide. So 0.15. So now you can plug into ammonium sulfide goes into 2 of ammonium and 1 sulfide, minus x molar, 2 times of x molar and x molar. Now you just 0.15 is the x molar, plug in, and that's how you want to do it. So separate steps, and you're thinking about x molar and how many times depending on the coefficient. In this case, 2 times for the ammonium, right? So we solved that beaker question basically. Now let's go to the other beaker. Ammonium chloride goes into ammonium plus and chloride minus. Now this one is easier because it's one coefficient, right? But still you can use the minus x molar, right? By the dissociation, you're going to get that. Yeah, so let's get the moles first. For zero point 0.4 moles, because it's a molarity given, and 0.4 mole over 1 liter times you have 0.025 liter. That's 25 mils convert into liter, right? So get the moles for that one. So in both, when you transfer, also you have the same number of moles, right? Nothing created, nothing destroyed. So 0.01 molar ammonium chloride. Now you divide by the total volume, which is the two beakers together, 0.1 liter, and that'll give me the molarity of ammonium chloride, right? So that is actually the x molar, right? Now write the formula, break the salt, dissociate the salt. It's 1 to 1, it's easy. Minus zero point 0.1 molar goes into 0.1 molar, 0.1 molar, right? Now ammonium is coming from two sources. So now we can add all the ammonium together from beaker A and beaker B. A gave you 2 times of 0.15 and B gave you 0.1 molar. So add together, that's the total ammonium. But molarities, you simply add them together, right? But the sulfide and the chloride is pretty easy. It's already done. It's whatever you got because it's one coefficient, right? So that's how you want to do those two mixtures come together, make one final mixture in this, right? Okay. We'll go to another question. This one is a bit more complex. Look at this one. Silver nitrate is given and you are trying to calculate how many grams, right? Look at this one. The grams should be connected to moles and the moles should be connected to the molarity. Now we know there's a connection of molar mass because grams moles is the only connection is molar mass. So the molar weight, right? That we need to calculate. So most of the time when you're given the formula, make sure you just get the right values. In this case, silver is 108, nitrogen is 14, O3 is 48. That will give you 169.87 when you get the actual values from the periodic table, right? But if you're not doing calculation of molar masses, just copy it from the Wikipedia, from the internet, right? Now, so what I know, molarity is moles divided by number of moles divided by liters, right? That's the molarity. So now I know two things. I know the molarity, I know the number of liters, right? Now you do the cross multiplication and we need to get the moles because that's what we sorted out, right? So 0.05 moles divided by liter, but here you have 0.25 liter, that's 250 milliliter divided by 1000, right? So simplified, you get the moles. Now, the moles of silver nitrate. Now, what we need to know is how many grams, right? So now, what do you do? So the mole should be cancelled out. So that should be in the denominator, right? Okay, so 169.87 grams on the top, mole to mole cancels out. Voila, you get the grams. Now, so the how many grams? Let's do the calculation here. So 2.12 grams. Now this actually, so that's the answer. And it should be dissolved in the 250 milliliter of distilled water. So that's the understanding. Now, if you have a bit of a question about how do you do it, you take a 250.00 milliliter volumetric flask. That's a precise one. Volumetric flasks are precise. Then you put a funnel on top of it and then measure the 2.12 using an analytical balance. It actually measures into 2.1200, right? And you put it in and add distilled water, roughly about half or two-third. Then shake it, swirl it, right? And let it climatize. That means it could be warm or cold. Let it settle and then add few drops from the dropper until it meets the meniscus. What's the meniscus? You look from the eye level and you can see the barrel and the meniscus should be touching the marker of 250 milliliter. So that's how you precisely make a stock solution, right? If it is relevant, you should try to understand that. Now, so the next part